Okay, let's wait for 5 minutes so that everyone can join. Then we'll start the tutorial. Okay. Okay, let's start the live session. So I am Pankaj Kapdi and NPTEL PMRF TA, and I'll be discussing some problems related to the lecture videos of this week. So the problems will be mostly based on the application of derivatives. So using the derivative to find maxima, minima, and decide whether the function is increasing and decreasing in a part of the domain. Okay, and we'll use first and second derivative test to find minima and maxima, and let's see how this can be done using derivative. So our first problem here. Okay, so for the next three problems, we'll assume that our function is this. Okay, so it's a product of two function. So, and you have to find out what are its critical points. Okay, so what is our function? Let me write once again. So my function is x to the power 2/3 into x plus 5. Okay, yes. Okay, and so I have to find the critical points of this function. So what are critical points? So critical points are zeros of the derivative. Okay, so a point C in the domain of the function, we call it, it's called a critical point if the derivative vanishes at that point. Okay, so such a point is called a critical point, and we have to find such critical points for this function, which this function can also be written. Okay, let's write it in this way. This is x to the power 5 by 3, right? Because 1 plus 2 by 3 is 5 by 3, plus 5 times x to the power 2 by 3. Okay, now we'll find its derivative. So what is the derivative of the function? It is equal to, so just apply the rules of derivative. We'll just differentiate this function and apply the rules of derivative. It says that if you differentiate x to the power of r, okay, so what we are using? We are using that if you differentiate two function, that is same as differentiating them one by one, right? Of g. So this is like the first rule, algebra of derivatives, and second is the differentiation of power function, x to the power r. So if you differentiate this, then you will get r times x to the power r minus 1. So these are rules we'll be using. Okay, so okay. So what is the derivative? It's 5 by 3 times x to the power 2/3, right? Plus 10 by 3 into x to the power 1/3. That is the derivative. Okay, so let's take 5 by 3 common, and you can see that we can also take x to the power 1 by 3 outside. And so what do we left? We left with x plus 2. Okay, if you multiply, then you will get this. Or you can also write it like 5 times x plus 2 and divided by 3 times the cube root of x. Okay, or let's write x to the power 1/3. This is the derivative of our function, and notice that f prime of minus 2, if you put x equal to minus 2, then it becomes 0. And further, f prime, this is not defined at x equal to 0, right? Because in the denominator we have x to the power 1/3, and therefore the derivative of the function is not defined at x equal to 0. Okay, but the given function is defined everywhere. Okay, so we can consider that its domain is the whole real line. It's defined everywhere. So what are the critical points? The critical points are those points where either the derivative is not defined or the derivative becomes 0. Okay, so C is called a critical point if either f prime C is 0 or the derivative is not defined. Okay, is not defined. So what are critical points in our case? So there are two critical points. So minus 2 comma 0. Okay, let's write it like this. X is equal to minus 2 and x is equal to 0. These two are the critical points for f function. Okay. Okay, so second option is correct here. We have two critical points, one -2 where the derivative vanishes, and one is x equal to 0 where the derivative is not defined. Okay, so any questions? I'll just wait for
No,
1 minute.
sir.
Okay. Okay, so if there are no questions, let's move to the next problem. So next problem, the function is remains same. So because the same function we will be using for these first three problems. And in the second problem, we have to find local minima and maxima if they exist when you restrict the function in the domain -3 comma 3. Okay, so we are restricting our function in this domain -3 comma 3, and we have to find the points. We have to decide what are points of local maxima or local minima, and you know that those points can only be critical points. Okay, so critical points are points of local maxima or local minima. So we have to analyze those two critical points which we have obtained in the last this problem, and these are -2 and 0. Okay, so let's recall what was the function. So, so function was 5 times x to the power 2 third. Okay, so that was derivative. Okay, 5 times x to the power third bracket in bracket x plus 5, right? And what was the derivative? We have computed that. Okay, 5 times x plus 2 divided by 3 times x to the power 1 third. Okay, so that was the derivative. And what are the critical points? -2 comma 0 are critical points. Okay, now we have to decide which critical point is a point of maxima or minima, or it may not be a point of maxima or minima. Okay, that can also happen. So for that, we have to find out what is the sign of derivative, how the derivative is sign is changing from either negative to positive or positive to negative in a small neighborhood of that critical point. Okay, so if let's say this is your x equal to c, that critical point, and it is the case that, okay, so if derivative, the sign of derivative is negative, that means function is decreasing near, you can have, you may be in a small delta neighborhood of your critical point c, and this is kind of local behavior of your function, that if on the left of c the derivative is negative, that means it is decreasing. On the right derivative is positive, that means it is increasing. That means at the critical point you should have a point of minima, right? So these kind of thing we have to analyze. Okay, so this is called first derivative test. Okay, so because here finding a second derivative will require a lot of computation, so we will not apply that second derivative test. We'll just apply the first derivative test. Okay. Okay, so what first derivative test says? Okay, so in the first derivative test, so if your derivative f prime changes its sign from negative to positive. Okay, so if on the left hand side of the critical point is negative and on the right hand side is positive, and why we have this kind of property, because we have these two properties, that if the derivative is positive inside the domain, okay, so let's say in the domain of the function or whatever the interval you are checking it, so if the derivative positive, that means f is increasing, okay, in that domain. And if the sign of derivative is negative inside the domain everywhere, then f is decreasing. So this we also know this property of derivatives. Okay. Okay. So using these the behavior of increasing and decreasing this nature of the function in a neighborhood, in the local neighborhood, in the near the critical point, we can determine if the point is a local maxima, minima, or not. Okay. So if sign changes from negative to positive, okay, so you can see that at x equal to c, if the sign changes from negative, so here the derivative was negative, sign of derivative, and here sign of derivative is positive, so it has a local minimum. Okay, so you can say that near x equal to c, then x equal to c is a point of minima. Okay, so this is called a first derivative test. And similarly, if f prime changes its sign from positive to negative, okay, positive to negative near x equal to c. Okay, so this sign change we are always taking from left to right. Okay, so then what happens? This x equal to c is a point of local. Okay, we also say that it's a local maxima. Okay, and why is happening? Again, I can draw a picture. Okay, so you have x equal to c, and locally the sign is changing from positive to negative. So initially it was positive and then it goes down. Okay, so positive means the function was increasing, and negative means function is decreasing. So the, at x equal to c, this is a point of local maximum. Okay, so this derivative test we will use to decide the nature of critical points. Okay, so notice the derivative f prime x. Okay, so it is 5 times x minus minus 2. Let's write in like this, and 3 times x to the power 1/3. Okay, so let's check x equal to minus 2. Okay, so we are near minus 2. So let's say x is less than minus 2. So we are very close to minus 2, but not equal to minus 2, because at when if x is minus 2, then it will become 0. So let's say between minus 2 and minus 3. Okay, it doesn't matter. X is less than minus 2. Then what is the sign of f prime? Is it positive or negative? But it can be. Okay, so you can see that the sign will be determined by the sign of these two factors. Okay, because of 5 by 3 is just constant. These they are already positive sign, just a constant. So x is less than minus 2. Basically, x is negative. So x is negative. So this x square 1/3 is also negative. Okay. So this has negative sign, minus. And okay, so this is x plus 2. And again, if x plus 2, so what is the sign of x plus 2? You can see that x is less than minus 2. That is x plus 2 is less than 0. Okay. So this you also gives that your x plus 2 also have negative sign. Okay, so the denominator and numerator both have negative signs. That means the overall expression has positive sign. Okay, so f prime x is positive. Okay, so what happens if x is greater than -2, but we are not making it 0? We are very close to -2. Okay, so what happens if x is greater than -2? Okay, still x is negative. Okay, so this expression is still negative, the denominator. But if x is greater than -2, then you can see that x plus 2 is bigger than 0, right? So x plus 2 is positive. So numerator has positive sign, denominator has negative sign. That means the overall sign is, what is the overall sign? It is negative, right? Okay, so and why it's happening? On this left hand side, we can write that if x is less than 2, if and only if x plus 2 is less than 0, and similarly x is bigger than -2, if and only if x plus 2 is positive. Okay, so these decide us to, okay, so these helps us to decide the sign of the numerator. Okay, okay, so what do we get from the first derivative test? That this derivative is changing its sign from positive to negative near x equal to -2. Okay, so therefore what will happen, this x equal to -2 is a point of local minima. Okay, oh, it's changing the sign from positive to negative. Okay, so local maxima, not minima. So this comes from the first derivative test. So any doubts? Okay, so now let's analyze the second situation, x equal to 0, the critical point x equal to 0. Okay, so if x is positive, then okay, so let me write the derivative here. It's 5 by 3 x plus 2 divided by x to the power 1/3. Okay, so you can see that if x is positive, denominator is positive, and x plus 2 is also positive, right? Because x is positive. So again, f prime x is positive, and if x is negative and we are not going very far, we are in the small neighborhood of 0, so we can assume that x lies between -1 and 0. Okay, then what will happen, f prime x, because if x is negative, then denominator becomes negative, but the numerator will be still positive. Why? Because x is, we are assuming that it is, yeah, it is negative, but it is greater than -1. Okay, so if you add to both sides, so this will happen if and only if x plus 2 will be greater than 1. Okay, and 1 is positive. That means the numerator is still positive, so the sign of the derivative is 0. Okay, so what is happening, the f prime x, the derivative, it changes its sign from negative to positive, right? On the left hand side of the 0, its sign is negative, and on the right hand side of 0, the derivative has positive sign. So again, by first derivative test, the critical point, which is x equal to 0, is a point of local minima. Okay, this we get. Okay, and there are no other critical points. Okay, in the whole real line, there are only two critical points, -2 and 0, and therefore we are inside this domain which is given to a -3, 3. Okay. So we got that -2 is a point of local maxima and 0 is a point of local minima. So the fourth option is correct. So any questions? Okay, so if no questions, then let's move to the next problem. Okay, so for the next problem, the function is still same, but you can see that we have restricted our domain of the function to -2, 0. Okay, so only this interval we are restricting it. So you can notice that the left hand side and right hand side of this interval both are the critical points. Okay, and inside the interval there are no critical points, and in the options we are asked that what are points of absolute maximum and absolute minimum. Okay, so this is an easy questions. This is an easy question. So we have again the same fx restricted to interval -2, 0. Okay, so notice that or observe that f has no critical points. Okay, so f does not have any critical points in this open interval -2, 0. Okay, so there are no critical points inside this interval because we know that the function has only two critical points. One is -2 and one is 0, right? The derivative vanishes at -2 and it is not defined at 0. So this was the derivative. Okay. And we already know that this -2 and 0, they are points of, one is local maxima. Okay, so -2 was the point of local maxima and 0 was the point of local minima, and there are no other critical points. So that means these point must be the point of local or the point of absolute maxima and minima, right? And we can also see that because x lies between 0 or let's say less than equal to -2. Okay, because x lies in this interval, that means the derivative, you can see that for the derivative in the denominator x to the power 1/3, that is negative, and x plus 2 is positive. That means the derivative is actually negative. Okay, because x plus 2 is positive and x to the power 1/3 is negative, so this thing is less than, or we can say that it is less than equal to 0. Okay, and let's not include x equal to 0. Okay, so for every x in this case. Okay, so this implies that the function is decreasing. F is a decreasing function in this interval. Okay, so now you can see that this here we have -2 and 0. The function just decreases from one point to another point. Okay, it's like that. So from graph you can also see that the -2 has to be the point of local or point of, in this case, global or absolute maxima, and 0 is the point of absolute minima, right? And that we can also see from the fact that inside the open interval there are no critical points. Okay, so only the endpoints are the critical points, and they are because the points of local maxima and minima. So in this particular restricted interval, these points are also absolute maxima and minima. Okay, hence x equal to -2 is a point of absolute maxima, and x equal to 0 is a point of absolute minima. Okay, so this first option is correct here. Okay, so any questions? Okay, so there are no questions. So let's move to the next problem. Okay, so for next two problems, we will assume that our function is this. Okay, so this gx, this is a rational function. So it's a quotient of two polynomials. One is x square minus 3 and one is a linear polynomial x minus 2. Okay, so you can notice that the function is not defined at x equal to 2. Okay, and you have to first okay, so looking at these options, you can see that you have to determine in which part of its domain the function is increasing or decreasing. Okay, so let me write this function. So this is our gx, which is x square minus 3 and divided by x minus 2. Okay, so this is our function, and because we want to know where it's increasing or decreasing, so we have to see we have to find the critical points, and we have to check the sign of derivative inside those intervals determined by the critical points. Okay, the interval separated by the critical points, and here you can see that x function is not defined for x equal to 2. Okay, so what is the domain of the function? The domain of this gx is everything except x equal to 2. Okay, so we have to remove this 2. Okay, so which we can also write minus infinity comma 2 and union 2 comma infinity. Okay, we have to just remove 2. So for finding this sign change of derivative, first we have to find the points of critical points, right? So for that, let's find out the derivative of g. So what should be derivative of g? So for that, we have to apply the quotient rule, which says that differentiate the function in the numerator, multiply it with the function in the denominator, and subtract the reverse process, that is x square minus 3, and the derivative of denominator is 1, and divided by x minus 2 whole square. Okay, so let's see what we get after the simplification. So we'll have 2x square minus 4x and minus x square and a plus 3, and divided by x minus 2 whole square. Okay, let's simplify it further. So we'll get x square minus 4x and plus 3 divided by x minus 2 whole square. Notice that we can factor the numerator. So how can we factor this numerator? We'll factor it into x, in this x minus 1 into x minus 3. Okay, so this is our derivative. This is the derivative of g. Okay, so what are critical points? So critical points of our function g are, so at which point the derivative vanishes. You can see that the derivative becomes 0 if x equal to 1. So you can say here g prime x is 0 if and only if x is either 1 and 3. Okay, so critical points are 1, 3, and 2 is also critical point, because at x equal to 2 the function, the derivative is not defined. Okay, so these are critical points, and these critical points divide our domain in 3 parts or 4 parts. So this is 1, 2, 3. So okay, so here we have these 4 open intervals. Okay, so A, B, C, D, these 4 intervals, and we have to check the sign of derivative inside all these intervals. Okay, so what was the derivative? Okay, let's write once again. It is x minus 1 into x minus 3 and divided by x minus 2 whole square. Okay, so what will happen to the sign of the derivative inside the first interval a? So you can say that if x is less than 1, then what will happen? Okay, so if x is less than 1, then what will happen to the derivative, sign of the derivative? Is it positive or negative? Okay, so if x is less than 1, then this first factor, you can see that this factor will become negative, right? And this is again negative. Denominator has this square, so it doesn't matter, its sign is always positive. So you can see that since for x less than 1, the both these factors x minus 1 and x minus 3, they are negative, their product is positive. Okay, so this sign is positive. Okay, so what will happen if x lies between 2 and 1? Okay, so if x lies between 1 and 2, so we will have again x minus 3 will be negative, this will have negative sign, and this x minus 1 will have positive sign, right? Because this time x is greater than 1. So if you subtract 1, then it will be still positive. But x minus 3 is negative, so the product is negative. Okay, so again, if x lies between 3 and 2, then what will happen? You can see that this the same thing will happen, right? X minus 1 is positive and x minus 3 is negative, so the derivative is still negative. So, and what will happen if x is greater than 3? And you can see that the derivative becomes positive, right? Why? Because x minus 1 is positive and x minus 3 is also positive. Okay, so this first one will imply that the function g is increasing, right? Because derivative is positive, increasing in this interval a. So what was a? Okay, let's not write a, let's write it minus infinity comma 1. Okay, so the second will imply that g is decreasing in interval 1 comma 2, this open interval. Third will imply that g is again decreasing in open interval 2 comma 3, and 4 will imply that g is increasing, right? In interval 3 comma infinity. Okay, so notice that we cannot say that the function is decreasing in this union of this interval, right? Okay, it is decreasing on the union of the interval, but we cannot say that the function is decreasing in the interval 1 comma 3, right? Because 1 comma 3 contains 2, and at 2 the function is not defined. Okay, so this is the analysis or the parts of the domain where the function is either increasing or decreasing. So let's choose what is the correct option. So it says that function is increasing in minus infinity comma 1 and 3 comma infinity. Okay, and the function is decreasing on 1 comma 2, right? So the third option is correct. Okay, so we cannot choose the last option, right? This 1 comma 3, because it contains 2. So we cannot say that function is decreasing on 1 comma 3. We can say that function is decreasing on the union of the interval 2 comma 3. Okay, so this is union, and this union is not equal to 1 comma 3. Okay, because 2 is missing. Here 2 is missing because both sides we have open intervals, but this contains 2. Okay, and this does not contain 2. So, so any questions? Okay. Okay, so no question. Let's move to the next problem. Okay, so again, the problem is about the same function g, but now this time you have to find out the nature of the critical points. Okay, so there were three critical points, 1, 2, and 3, and you have to tell me which point is a point of local maxima and which one is point of local minima. Okay, so let's recall that what was the function. Function was gx equal to, okay, so it was x square minus 3 divided by x minus 2. And what was its derivative? This was x minus 1 into x minus 3 and divided by x minus 2 whole square. And now notice that for finding this local minima and maxima, we have to check the sign of the derivative, right, in the local neighborhood of those critical points. Okay, and now we already know where the derivative is positive or negative, right? We know the nature of the function, either it is increasing or decreasing inside those intervals, and they will help me or help us to find out the nature of critical points. Okay, so what are critical points? The critical points are, critical points are 1, comma 2, comma 3. Okay, so there are three critical points, and we also know the sign of the derivative, right? We have already determined. Okay, so let me write a positive sign because here in the whole interval the derivative is positive. Here the derivative is negative, derivative is again negative, and derivative is again positive. Okay, so if you consider the first critical point, that is this one. Okay, and if you say locally in a small neighborhood, the derivative, the sign of the derivative is changing from positive to negative, right? Okay, so it was initially increasing, then the slope becomes 0 at 1 because it's a critical point, and then after that the function started to decrease. Okay, so you can see that the first derivative rule, it will tell us that x equal to 1 is a point of maxima, right? Local maxima. Now locally near to, the sign of the derivative is negative. Okay, on the left hand side and also on the right hand side. That means it is decreasing and it decreases further. Okay, it decreases continuously, right, from left to right. So there is no change of sign, and because there is no change of sign, there is no point of local minima or maxima. Okay, now at x equal to 3, you can see that the sign is changing from negative to positive, right? That means the function was, okay, so initially the function was decreasing and then it started to increase. So it will be like this, something like that. Okay, so it was decreasing like this. If you continue this path, so then it will increase this way, right? So the point of minima. Okay, so what we can write? So we can write that at x equal to 1, the derivative g prime changes its sign from positive to negative, and this implies that x equal to 1 is a point of local minima. Okay, similarly at x equal to 3, the derivative g prime changes its sign from this time negative to positive, right? And therefore x equal to 3 is a point of local. Okay, again, this was the point of maximum, local maximum, and this is a point of local minimum. Okay, and we have one more point at x equal to 2. Okay, so at this point the function is not defined, but locally near to the function is defined, right? And its derivative is also defined. So okay, so let's say not at x equal to 2, near to. Okay, so near x equal to 2, the derivative g prime does not change its sign. Okay, so we cannot say anything about this. Okay, so this is the analysis of these critical points. So you have local maxima at x equal to 1 and local minima at x equal to 3. So last option is correct here. So any questions? Okay, so if there are no questions, let's move to the next problem. Okay, so this is a descriptive type of problem where you have to minimize or maximize some area or volume. Okay, so again, so derivative will help us to minimize or maximize the use of the material if you are making some box or some poster. Okay, so here we are making some poster, rectangular poster. Okay, so it says that we are designing a rectangular poster to contain 50 centimeter of printing. Okay, so the 50 centimeter square, that area should be the printing area, and 4 centimeter margin at top and bottom that we have to leave where there is no printing, and 2 centimeter margin at the left. Okay, this is like the situation. Okay, so let's say I leave some margin on the bottom, left, right, and at top everywhere, and this is my printing area. Okay, so here I will print, and this is this empty place, the border. Okay. And this is a rectangular sheet, and this printing area is we know that it is 50 centimeters square. Okay, and so what are the margin? So at top and bottom, so margin is 4 centimeters. So this length is 4. Okay, this length is again 4, and the right side and the left side, right? The margin is 2 centimeter. Okay, so this length, this is 2. Similarly, this length is also 2. Okay. So if we assume that our what should I say? So this is the length and breadth or height. Let's call that it is x centimeter, and because the area is in the centimeter square, so let's call this is x centimeter, and this is my y centimeter, or conventionally let write this horizontal one at x, right? Like x-axis, and this is y centimeter. Okay, so now I know the area of this particular part, and I have to minimize the overall area, right? I have to minimize the overall area. Says that find out the length, and we have to find the ratio of this length, the vertical length and horizontal length, so that the amount of paper is minimum. Okay, so that means we have to minimize the area. So what is the area? Area is x times y. So aim is, what is our aim? Aim is to minimize area of cardboard or whatever poster. Let call this poster as, the area of the poster as a. So we have to minimize this a. And what is this a? This is x times y, right? Because that is the area, the length times height. Okay, now notice that you cannot have x to be less than equal to, your x must be greater than 4, right? Because on the left hand and right hand side you have to you are leaving a margin of 2. So if you add this, you will get this condition that x must be at least 4. Okay, and similarly y must be at least 8. Okay, so this condition we also have. That means xy, the area has to be at least 32. Okay, but obviously the 32 will not be minimum, because if 32 is minimum, that means x must be 4, y must be at 8, and there is no printing area then. But we also have this constraint that the printing area should be 50 centimeters square. Okay, so let's use that constraint. Okay, so how do we find the printing area? So printing area is this length into this length, right? And what are these length? You can say that, see that this length is x minus 4 and this length is y minus 8. Okay, so we have the print, because we want that printing area should be 50, so that gives us that x minus 4 into y minus 8, this must be equal to 50. Okay, so what we will do, we will extract y from here. So y minus 8 is 50 divided by x minus 4. Okay, so notice that we are not we are assuming x to be greater than 4. So x is not equal to 4. We are assuming x is greater than 4. So we can divide by x minus 4, right? So this constraint gives me that y must be 8 plus 50 divided by x minus 4, right? And now what is my area? Area was a, which is x times y, and now I have y in terms of x, right? I wanted to reduce one variable. Okay, so I initially we had two variables, but we also had one constraint, and that's one constraint will help us to make this area as a function of single variable, which is x, right? So it's 8 plus 50 divided by x minus 4. Okay, let's call this function as f of x. It's a function of x. So my area is a function of x, or we can say that the area is function of x, a of x. Okay, instead of fx. Okay, so I have to minimize. So what is my aim? Aim was, again, it's the same thing. Minimize ax, the function ax. And what is this function? Let's take the product. It is 8x plus 50 times x divided by x minus 4. Okay, now to minimize this, we have to obviously find the critical point and check if that critical point is a point of maxima or minima. So we want a point of minima, so that at those values of x and y, my area will be minimum, and I can make a poster of minimum area such that the printable area is 50 centimeters square. Okay, so that is the constraint. For that, we have to find the derivative and see where the derivative vanishes. Okay, so let's see what is the derivative. Okay, so if you differentiate, you will get 8 plus, now apply the quotient rule again. So 50 times x its derivative is 50, multiply it by x minus 4, subtract 50 times x, right? Because the derivative of x minus 4 is 1, and divide by x minus 4 whole square. Okay, so let's simplify this. We'll have 8 plus, you can notice that if I open this bracket, then 50x will cancel with this 50x, right? These 50x will cancel with each other. And I left with a negative sign, 200 divided by x minus 4 whole square, right? Okay, so how do we find the critical points at which derivative becomes 0? Now we don't know. Let's take 8 to be common. Okay, and we can write it as x minus 4 whole square minus, right, 25 times 8 is 200. So the derivative can be written like this. Okay, so let's simplify further. We have to find out where the derivative becomes 0. Let's write it here only. So let's open the bracket. So you can notice that the denominator is never 0. So this factor will not contribute to anything. And in the bracket, we'll have x square plus 16 minus 8x minus 25. Okay. So the derivative is, we have 8 times x square minus 8x plus 9, right? Okay, it's minus 9, not plus 9. And divided by x minus 4 whole square. Okay, now what we will do, we will factor the numerator again 8 times. So is this correct or we making some mistake? Okay, so up to this point everything is correct. Okay, let's see how we can factor it. We can write x. Okay, so x plus 9. Let me write x plus 9 and x minus 1. Then I'll get plus 8x. So I have to change the sign in the factorization. Okay, so x minus 9 and x plus 1. Okay, so this must be the factorization. So if you take the product, you will get x square minus 9x and plus x. That will give you minus 8x and then minus 9. Okay, so this is the factorization. This is my derivative. Okay, so where the derivative becomes 0, what are the critical points? So a prime x is 0 if and only if x is equal to minus 1 or x is equal to 9. Okay, so notice that x cannot be negative. Okay, so this critical point we have to ignore, x equal to minus 1. Okay, let's ignore the critical point x equal to minus 1. Okay, so since x is positive, so these are length and height of the cardboard, we only consider x equal to 9. Okay, so we'll consider only this critical point. Okay, so tell me what is the sign of the derivative is near 9. Okay, so let me write derivative once again. This is something x minus 9 into x plus 1 divided by x minus 4 whole square with some factor, right? Some 8. Okay, so notice that this will not determine the sign, right? These thing will not determine the sign because 8 is already positive, x minus 4 whole square is already positive. So near 9, so if x is less than 9 and it's very close, let's say between 8 and 9, then what is the sign of the derivative? Right, it's the sign is negative, right? Why? Because if x is less than 9, that means x minus 9 is less than 0 and x plus 1 is positive. And if you take x to be bigger than 9 and let's say less than 10, what is the sign of the derivative? It is positive, right? Why it is positive? Because both the x minus 9 and x plus 1 are positive. So this says that the near x equal to 9, the derivative a prime changes its sign from negative to positive, right? And this implies that from the first derivative test, this implies that x equal to 9 is a point of minima. Okay. Okay, so x is a point of minima, and now we have to find y also. So what is the y? Okay, so we know that y is this. This is our y. This is 8 plus 50 divided by x minus 4. 8 plus 50 divided by x minus 4. Okay, so now we know that x is 9, so this is 8 plus 50 divided by 9 minus 4. So 9 minus 4 is 5, divide by 50, then 10 plus 8, it's 18. Okay, okay, so we get the height. All right, we get the height and length of the cardboard. So this thing is 18 and this thing is 9. And what we are asked, that what is the ratio of vertical length to the horizontal length. Okay, so we have to find the ratio of vertical and horizontal length. Okay. So this ratio vertical divided by horizontal, right? So vertical was y and horizontal is x. So y was 18, horizontal was 9. So the ratio is 2, right? This last option is correct. Any questions? Okay, so if there are no questions, let's move to the next problem. Okay, again you have a function. It's a quadratic function. It's a polynomial ax square plus bx plus c, and you have to again find out what is the nature of this function, like where it is increasing or decreasing, and the sign of ABC is given. So A is positive, B is positive, C is negative. Okay, so this information is given. So let's find out the critical points of this function. Okay, so what our function is? This polynomial, quadratic polynomial ax square plus bx plus c, given that a is positive, b is positive, and c is negative. Okay, so this information I have. Okay, so to find the critical points, compute the derivative and find its zeros where the derivative becomes 0. Okay, so what is the derivative? It is 2ax plus b, and take 2a common, you will get x plus b by 2a, right? We can divide by a because a is positive, it's not 0. Okay, so where the derivative becomes 0, so you can see that the derivative becomes 0 if and only if x is minus b over 2a. Okay, so this is our critical point. Now just find out the change of sign of this derivative near this point minus b by 2a. Okay, so okay, so what is the sign of, first let's say okay, it doesn't matter what is the sign of b by minus b over 2a. So you can notice that if x is less than minus b over 2a, then if this happens, then what is the derivative? What will happen to the derivative? Note that this derivative here, you can see that I have taken it 2a common. Okay, so the sign of this derivative will depend on the sign of a and on the sign of this factor. Okay, so sign of this constant a. So what is the sign of a? Sign of a is positive. Okay, so this a is positive. So the sign of f prime will only depend on this x plus b by 2a. Okay, so if x is less than minus b over 2a, that means fx, that the sign of the derivative is negative, and that will say that f is decreasing. Okay, so f is decreasing in the interval minus infinity comma minus b over 2a. Conversely, if x is bigger than minus b over 2a, then the derivative is positive, and that will imply that f is increasing. Interval, the remaining minus b over 2a up to infinity. Okay. Okay, so which options are correct? Initially, it was decreasing in minus infinity comma minus b over 2a, and okay, so okay, so you can see that this is a wrong. This one is wrong because on this interval the function is decreasing. These two are wrong because the critical value is not minus b by a, it is minus b over 2a. So this option must be correct. But here I see both decreasing, so there must be a typo. Okay, so let's rectify the typo. I think this is typo. This is increasing. Okay. Okay, so option C is correct. On the left of minus b over 2a, the function is decreasing, and on the right of minus b over 2a, the function is increasing. Okay, so the option C is correct. So any questions? Okay, so if no questions, let's move to the next problem. Okay, so this will be our next problem. Okay, so let's wait for 5 minutes. Okay, I have to go to washroom. So Okay, so let's move to the next problem. So here again for the next three problem, our function will be same. Okay, so this will be our function for these first next three problems. And again, we have to find out what are the critical points, its behavior, where it is increasing and decreasing, and what are the nature of the critical points, if they are local maxima or points of local minima. Okay, so let's. So what is our function? This is fx equal to 7 plus x divided by. Okay, so we don't have to divide. It's 11 minus 3x to the power 1/3. Okay. So notice that the function is defined everywhere, right? So the domain is whole real line. Let's find out its derivative. So for finding the derivative, apply the product rule and the chain rule. Okay. So for the product rule, just differentiate the first function and multiply by the second one. So if you differentiate the first, you will get 1. So it's just 11 minus 3x to the power 1/3. Okay. Now plus again first function and differentiate the second one. So if you differentiate the second one, you will see first a power function. So differentiate the power function, apply the chain rule, you will have 1/3, and then you will have this power to be minus 2/3, right? Yes, and then differentiate 11 minus 3x. So if you differentiate 11 minus 3x, you will get a minus 3. So that will cancel out with here, and you will have only this much minus this. Okay, now we'll just simplify this derivative. What can we take common? Okay, let's, if I take this to be common, then I left with 1 minus 7 plus x into, okay, so this says that minus 1 plus 1/3, which is minus 2/3. Okay, so I think we should take minus 2/3 common. Okay, let's take minus 2/3 to be common. So in the bracket, I'll be left with 11 minus 3x, right? 1 minus 2/3 is 1/3. So 11 minus 3x and minus 7 plus x. Okay, this is better expression. Okay, so again 11 minus 3x to the power minus 2/3. Now open the bracket, we'll have 11 minus 3x minus 7 minus x. We can write this derivative as, what is 11 minus 7 is 4. This is 4 minus 4x. So if you take 4 common, you'll have 1 minus x, and in the denominator you have 11 minus 3x to the power 2/3, right? So this is our derivative. So now what are the critical points? The critical points are just the zeros of the derivative, and if the derivative is not defined at some point, then those are also critical points. So you can see that at x equal to 1, the derivative becomes 0. And at so if the denominator becomes 0, the function is, the derivative is not defined. So when can the denominator become 0? The denominator can become 0 precisely at 11/3, right? Okay, so the derivative is 0 if and only if x is 1, right? And the derivative is not defined. Okay, and at x equal to 11/3, the derivative is not defined, right? Yes. So what are the critical points? These are the critical points. Okay. Critical points of f are x is equal to 1 and 11 by 3. So we have two critical points, 1 and 11 by 3. Third option is correct. So we have these two critical points. Now, okay, so any questions? Okay, so no questions. Let's move to the next problem. Okay, so the next problem is about the nature of these critical points. Okay, so what is happening at x equal to 1? So in this problem, it's asked that what happens for x equal to 1. Okay, is it a point of local maxima or absolute maxima or local minima or absolute minima? Okay, so let's recall that the derivative. What was the derivative of f? The derivative was 4 times 1 minus x divided by 11 minus 3x to the power 2/3, right? Now we have to determine the nature of x equal to 1, the critical point x equal to 1. So what we will do, let's check the sign of the derivative when x is less than 1. Okay, so if x is less than 1, okay, let's write it more in this way. This is 4 times 1 minus x, and I let it 11 minus 3, 11 by 3 minus x to the power 2/3. So I am taking a 3 outside. Okay, so outside I'll have a 3 to the power 2/3. Okay, so I'll write this in this way, the derivative, because then these are just constants. Okay, so if x is less than 1, you can see that 1 minus x is positive, right? 1 minus x is positive, and what about 11 by 3 minus x? We have to, okay, so we don't have to check the sign of this denominator. Okay, so this we don't have to check, right? Because why we don't have to check? Because this 11 minus 3x, this is just square of this thing, right? So in the denominator, because we have a square, so we don't have to check the sign of the denominator because it will be always positive. Okay, so if x is less than 1, that means 1 minus x is positive, and that will imply that the derivative is positive. And if x is bigger than 1, then the 1 minus x is negative, and that will imply that the derivative becomes negative. So at x equal to 1, the derivative changes its sign from positive to negative, and that will imply that x equal to 1 is a point of local maxima, right? Okay, and now there's one more critical point, and that critical point is 11 by 3. Okay, but we have to check only at x equal to 1. So okay, so at x equal to 1, we have a local maxima. But for absolute maximum, we have to also check the nature of 11 by 3, right? Because it may happen that 11 by 3 is also a point of local maxima. So we have, for finding the absolute one, we have to compare those two maxima. So let's check for 11 by 3 also. Sign of 11 by 3. Okay, so observe that this 11 by 3 is bigger than 9 by 3, right? Which is just 3. Okay, so 11 by 3 is greater than 3. That we'll remember. And so now we have to find the sign of the derivative. So what was derivative? Let's write here once more. This is 4 times 1 minus x divided by 11 minus 3x to the power 2/3. Okay. So the sign of this derivative will only depend on this 1 minus x. Okay. So what will happen if we are left of 11 by 3? Okay. And let's say bigger than 3. Okay, so I'm assuming that x is bigger than 3 and it's less than 11 by 3. So if this happens, then what is the sign of the derivative? Okay, so you can see that I'm taking x to be bigger than 3. That means the minus x is less than minus 3 and 1 minus x is less than 1 minus 3, which is minus 2, which is less than 0, right? So the simple as that the sign of the derivative is negative. Further, if x is bigger than 11 by 3 and let's say lies between 4 and 11 by 3, then what is the sign of the derivative? Again, let's do some calculation. So x is bigger than 4. So you'll see that you will again have 1 minus x to be less than, right? 1 minus x to be less than 0. So the f prime is again less than 0. So because the derivative does not change sign, so 11 by 3 is not a point of extrema. So, so there is only a local maximum. There are no local minimum. There is only a single local maximum, and that will become the absolute maximum. Okay. So at x equal to 1, we have a local maximum and an absolute maximum. Okay. So x equal to 1 is a point of absolute maximum also. Okay. So the second option is correct. Let's find out these maximum values. What are the, okay, because the second question asks this thing. Okay, so what is the maximum value and minimum value of the function? Okay, so let's find out the maximum and minimum value of the function. So what was our function? So our function was 7 plus x times 11 minus 3x to the power 1/3. Okay, so this is our function, and now we know that x equal to 1 is a point of absolute maxima and local maxima. So at x equal to 1, what is f of 1? Just put 1. So 7 minus 1, 11 minus 3 to the power 1/3. Just 6 times, what is 11 minus 3? 8, its power 1/3. Just 6 times 2. Okay, so this is 12. And you can see that if you put x to be equal to 11 by 3, so what is f of 11 by 3? So you can see that this part will become 0. So f of 11 by 3 is 0. So the maximum value is 12. So I think there is again a typo. right? The function is 7. Okay, 7 plus x minus. So the function is 7 plus x. So 7 plus 1. So this will become 8. Okay, so 8 times 2 is 16. Okay. So at 11 by 3 is 0. So you may say that the 0 is the minimum value. But notice that if you approach infinity, okay, if you take the limit of this function as x goes to minus infinity of your function, then this is minus infinity, right? And therefore f cannot have a local no, x cannot have a any minimum value. Okay, so the maximum value of the function 16, and it has no minimum value. Okay, so on the first option here is correct. So any questions? Okay, so if no questions, let's move to the next problem. Okay, so for next two problems, we'll assume that our function is this: gx equal to ax plus b divided by x square minus 1. Okay, and is given that gx has a local extrema at x equal to 3, and that extreme value is 1. Okay, so if that happens, then you have to find out what are these constant a comma b. Okay, so our gx is x plus b divided by x square minus 1. And what is given? Given that g has an extremum at x equal to 3. Okay, at x equal to 3, and what is the extreme value? Extreme value is 1. Okay, so that means if x equal to 3 is an extreme value, that means it's a critical point. Okay, this statement just imply that x equal to 3 is a critical point. Okay, so if x equal to 3 is critical point, that means the derivative must be 0 at that point. That means the derivative of 3, this will become 0. Okay, so let's find out what is the derivative. Okay, let's find out what is the derivative of our function, which is given by ax plus b divided by x square minus 1. So for finding this derivative, we will use the quotient rule. Okay, so how do we differentiate this kind of function? Just differentiate the numerator. You will get a multiply by x square minus 1, subtract from ax plus b times 2x, and again divide by x square minus 1 to whole square. Okay. Just simplify the numerator part. So you will have x square minus a, and then minus 2x square and minus 2bx. This we have in the numerator. So notice that the derivative is not defined at x equal to plus minus 1, and even the function is also not defined at x equal to plus minus 1. So let's assume that x is not equal to plus 1 or minus 1. Okay, so that means the critical point, which is x equal to 3, that means at that point derivative must vanish, right? Because at x equal to 3 the function is defined, the derivative is defined and everything. So the derivative must vanish at x equal to 3, and that will use here. First let's simplify this. This will just give us a times x square minus 2bx minus a divided by x square minus 1 the whole square. Okay, so this is our derivative of a. Okay, now since 3 is an extreme value, that means g prime 3 is 0, and that will imply that. So what we will do, we will just put 3 in this derivative. So what we will have, minus 9a minus 6b and minus a, and so it doesn't matter what is in the denominator, because ultimately this is 0. So this will just give us one equation, that 6b and plus 10a, this is 0, which is just equivalent to, okay, let's leave it like this. So this gives us one relation between a and b. Okay, so another relation we get from the second information. The second information says that the extreme value is 1. Okay, so the extreme value is 1 means if you put 3 in the function g, you should get 1. Okay, so g of 3 is 1. So since g of 3 is 1, that will give us that 8 times 3 plus b divided by x square minus 1, this is equal to 1. Okay, and we are putting x equal to 3, so here also x equal to 3, so 3 square. Okay, now this relation gives us 3a plus b is equal to 8, right? This is our second equation. So now we have to solve these two equations. So how do we solve? Now notice that 3a plus b is equal to 8. Is this equation is just equivalent. Okay, so what I will do, I'll multiply by 3. So this will become 9a plus 3b equal to 24, and then this equation is just equivalent to 3b plus 5a becomes 0. Okay, so now this first equation gives me that 3b is equal to minus 5a. Okay, and this we also write at 2 because they are equivalent equations, so it doesn't matter. So now we'll put this thing inside 2. So the equation 2 will now become 9a minus 5a equal to 24. Okay, so if I subtract, then I'll get 4a to be equal to 24, and that will give me a to be equal to 6. Now a is 6, and we have this lesson that 3b is equal to minus 5a. So if you substitute a equal to 6, then you will have 30, and that will give us that b must be minus 10. Okay, so a is 6 and b is minus 10. This we wanted to find. A is 6, b is minus 10. So the third option is correct here. So any questions? Okay, so if no questions, let's move to the next problem. And next problem is also related to the previous one. Uh, Now you know that x equal to 3 is an extreme extrema, but you don't know if that extrema is a local minima or local maxima. So we will find out. So what will happen? So if x is equal to 3 is a local maxima or local minima, because all these options they ask about the nature of this critical point x equal to 3. Okay. Now this x equal to 3 is an extreme value only when only when a is 6 and b is minus 10. So we'll assume that our function is like this. Okay, so now what is our function? Gx. For our function it was initially ax plus b, but a is 6, so it is 6x plus b is 10, so this is 6x minus 10 divided by x square minus 1. So this is our function. Okay, and the derivative we also have calculated, because we will need that. So what was the derivative? Right, so this was the derivative. It is minus ax square minus 2bx minus a, right, minus ax square minus 2bx minus a divided by x minus 1 whole square. But now we know that a is equal to 6, so all a is 6, b is minus 10. So if I put a equal to 6, then I have minus 6x square and b equal to minus 10, so I have plus 20x and minus 6 divided by x minus 1 whole square. So what I'll do, I'll just take something common. So I'll take 6 minus 6 to outside, and the bracket I left with x square minus 20 divided by 6, which is 10 by 3, right? And plus 1, and this everything divided by x minus 1 whole square. Right, why we are doing it? Because we want to find the nature of the derivative near x equal to 3, right? The x equal to 3 was the extreme value. Okay, so if I put x equal to 3, then this will cancel. Okay, the 3 is the extreme value. Okay, that is fine. So let me factor this quadratic thing. Okay, so how do we factor it? We want product to be 1 and sum to be 10 by 3. So what are the roots? Or if I factor this one, 3x square minus 10x plus 3. Okay, so what are the roots? 10 plus minus 100 minus 36 divided by 6, right? So 10 plus minus 100 minus 36 is 64. The square root is 8 divided by 6. So I have two roots, 10 plus 8, 18 by 6, and 18 by 6 is 3, and 10 minus 8, it's 2 by 6, which is 1 by 3. Okay, so if I take only this much common, 2 common, so I left with 3 here and a 3 here. So this was a derivative. So if I factor this, then I'll get x minus 3 into x minus 1/3 and divided by x minus 1 whole square, right? Okay. No, still something is not right. They are not equal. So I have to divide by, I have to multiply by 3, right? Yes. So this x minus 3 because I have to take 3 common. So, okay. This will be 6. I have to multiply also by 6. Okay. Now I think this should be correct. So x square minus 1 and I'll have a minus 3x and minus x by 3. If I add, then I have minus 10x by 3. Okay, so this is correct. Now you can see that we have two critical points, right? The derivative will become 0. So what is the derivative? Let me write once more. The derivative was minus 6 x minus 3 x minus 1 by 3 divided by x minus 1 whole square. Now notice that the derivative becomes 0 if and only if x is 3 or 1 by 3, right, at this point. So 3 is a point of extrema, but we have to find its nature. Okay, so let's find out if what happens if x is less than 3. Okay, so if x is less than 3, then so let's assume that it is not 2 negative, so it's lie between 2 and 3, and 1 by 3 is positive, right? So you can see that if x is less than 3, then this will become negative and this will remain positive, right, because x is still bigger than 2. So, and we already have a minus 6 outside, so these two will make sure that the product has positive sign. Okay, so if this happens, then the sign of the derivative is positive, and if x is bigger than 3, okay, then the sign, what will happen, because if x is bigger than 3, this is positive, but outside we have a minus 6, so sign is negative. Okay, so now notice that the derivative is changing its sign, right? Sign from positive to negative near x equal to 3. Okay, and now our first derivative test will give me by first derivative test x equal to 3 is a point of local maxima. Okay, so x equal to 3 is a point of local maxima, but you can see that we have one more point x equal to 1 by 3. This 1 by 3 is also a critical point, right, because we have noticed that this was our derivative and derivative becomes 0 even if x is equal to 1 by 3. And in these options, we have to all, according to these options, we have to also find the nature of x equal to 1 by 3. Okay, so these two options are cannot be true, because at x equal to 3 there is a point of local maxima. So let's find out the nature of x equal to 1 by 3. Okay, okay, so again for convenience, let's write what is the derivative. It is minus 6 times x minus 3 x minus 1 by 3 and divided by x minus whole square. Okay, in the denominator we have a always have a positive sign. So, and outside this minus 6 we have a negative sign. So we have to check the sign of these two linear product x minus 3 and x minus 1 by 3 near 1 by 3. Okay, so what will happen if x is less than 1 by 3? Okay, so if x is less than 1 by 3, then you can see that x minus 1 by 3, this is less than 0, and also this x minus 3, this is also less than 0, right? Because x is smaller than 1 by 3. Okay, so x minus 3 is less than 0 if and only if x is less than 3, but we are given that x is less than 1 by 3, which is less than 3. That means x minus 3 is also negative. That means we have three negative signs, right? This one is negative, this is negative, this is negative. The three negative signs will make a negative sign. Therefore, it implies that g prime x is also negative. Okay, so what will happen if x is bigger than 1 by 3? Okay, and now assume that it is less than 3 or very well less than 1. Okay, let's not make it too large because we are in a small neighborhood of 1 by 3. Okay, so if this happens, then x minus 1 by 3 is positive, but x minus 3 is still negative. Okay, so x minus 1 by 3 is positive, but x minus 3 is negative. So we have that this part is positive, this part is negative, and we have a minus 6 outside. That means we have two negative sign in the numerator. That will make everything positive, right? So this implies that g prime x is positive. Okay, so what is happening? So near x equal to 1 by 3, the derivative g prime x changes its sign from negative to positive, right? And because changing its sign from negative to positive by first derivative test, is x equal to 1 by 3. Okay, so x equal to 1 by 3 is a point of local minima, right? So now we have nature of all the critical points. One is local maxima, one is local minima. So the last option is correct. This one is also false. Okay, so any questions? Okay, so if no questions, let's move to the next problem. So I think this is the last problem of this session, and we have 10 minutes left. So let's do this problem. This is again an application of the derivative. We have to find out, we have to maximize some area of some triangle, and the triangle has some properties. So what are its properties? The first thing is that it's an isosceles triangle, right? Okay, so this is an isosceles triangle. So what are isosceles triangle? These are triangle which have two sides equal. Okay, so these two sides, let's say they are equal, and then this is the base of the triangle, isosceles triangle, and this is the vertex of this isosceles triangle. Okay, with respect to those two sides which are equal. Okay, and it's given that there is a curve, and what is this curve? This curve is y to be equal to 27 minus x square, right? So what is y, the curve of y equal to x square or y equal to minus x square? It is this parabola, right? This parabola is y is equal to minus x square, but our curve is y equal to 27 minus x square. So we are adding 27 to minus x square. That means, let's say we have here 27. That means now our parabola is like this. This is our parabola, and it's given that this isosceles triangle had its base parallel to x-axis. Okay, so the base is parallel to x-axis and its vertex at the origin. Okay, so what is happening that let's say this is our origin. So there is an isosceles triangle like this. This is its vertex at the origin. Its base is like parallel to x-axis. This is our x-axis. Okay. Okay, but it's the vertices of its base are on the curve. Okay, so it's like the curve is passing like this, the parabola, and the both these vertex are on this parabola, okay, except this vertex. So one vertex is at the origin and these two vertex are on the parabola, and it is like this is 27 point, okay. And you can see that uh, this is x and this is equal to y length, okay. Let me make a neat figure. So what is happening, we have a point 27 and we have this parabola, okay. And now we have a triangle whose vertex is at the origin and its base is parallel to x-axis. This is x-axis, and other two vertex are both on the curve parabola, okay. And this is base, okay. Assume that it is parallel to x-axis, okay. Now this is a point which is x comma 27 minus x square, right? This is the point x comma 27 minus x square. So what is this length? This length is equal to x, right? This length is equal to this length x. And what is this length? This length is equal to y, okay. So what is the height of our triangle? So height is y, and what is the base? The length of the base, right? So this length is x and this length is also x. Okay, so assume that x is positive, well, length, because we are talking about the length. So the base length of the base is 2x. Assume that x is positive. And what we do, we have to find what is the largest area of such a triangle. Okay, so we have to maximize the area of this triangle. So what is our aim? Maximize area of such a triangle. Okay, so what is our area? Let's find out. So the area of the triangle is equal to always half into the length of the base and the height. Height is y, okay. Now because y depends on x, so you can also write that. Okay, so what is area? The y is equal to 27 minus x square, and therefore you can write area as a function of x. It is equal to half into 2x. Inside the bracket we have a 27 minus x square, okay. Okay, you have to maximize the area, and for that you have to find for how much larger the base should be, right? The base can be like very large, like this, right? Because so this angle, if it is like this, and the area will be larger, or if you if the base is smaller, area may be smaller, right? We don't know, we have to maximize, we have to find such a value of x, the extreme value, so that at that point the function attains its maxima, okay. So let's write finally what is our function. Our function is, you can see that these two will cancel, so our function is 27x minus x cube, okay. So for finding to maximize this function, we have to first find the critical values. So what are the critical values? For that we have to find the derivative. So what is the derivative? It is 27 minus 3x square, right? So what is that? Let's take 3 to be common, and then we'll have 9 minus x square, which is equal to 3 times 3 minus x into 3 plus x. So what are the critical points? Of this function ax, these are plus minus 3, right? But we are saying that our this x is the length of the function, right? We are always assuming that x is length, so we are assuming that x is positive, okay. So we have to only consider the critical point which is positive, okay. So we only consider the critical point x equal to this plus 3. Okay, so we have to check the sign of the derivative near plus 3, or we can apply a second derivative test also, right? Okay, so this so till now we have not used second derivative test, so let's, because this time the derivative is the first derivative is very simple, let's apply the second derivative test. What is a double prime of x? Okay, you can see that the derivative is 27 minus 3x square, right? So this time the derivative is minus 6x, right? And if you plug plus 3, then you will have minus 18, which is negative. Now from the second derivative test, the second derivative test says that if at a point the second derivative becomes negative, that means it's the point of maxima. Okay, so we can write that by second derivative test, x equal to 3 is a point of local maxima. And what is the maximum value? Okay, so the maximum value is basically the maximum area, because the value is basically the functional value and the function is the area, which is just maximum area. This is equal to a of 3. What is a of 3? The a function was 27x minus x cube. So 27 into 3 minus 3 cube. Okay. What is 3 cube? It is 27, right? So take 27 common, multiply by 2, you will have 54. So the maximum area is 54. For the base 6, for a triangle with base 6, the maximum area is 54. The last option is correct. Okay, so with this problem, so I think this was the last problem. So if there are any questions, then I can answer. Okay, so if there are no questions, then thank you very much for joining this session. So we can end our live session here at this point, and we will meet next week with a new set of problems. So for now, we can sign off.